What is Apache Spark? Have you ever wondered how tech giants like Netflix and Amazon process enormous amounts of data in real time? The answer lies in one of the most powerful big data engines in the world, Apache Spark. In the age of big data, processing vast amounts of information quickly and efficiently is essential. Whether it's for real-time analytics, machine learning, or large-scale data transformation, traditional systems often fall short. Apache Spark steps in to solve this problem with its lightning-fast cluster computing capabilities. In this video, we'll discuss what Apache Spark is, how it works, its core components, and why it has become a go-to tool for big data professionals across the globe. Apache Spark is an open-source, distributed computing system that's built for speed, ease of use, and sophisticated analytics. It was originally developed at UC Berkeley's and later donated to the Apache Software Foundation, where it quickly became a key player in the big data ecosystem. But what makes Spark so special? Unlike traditional systems like MapReduce, which write data to disk between every operation, Spark keeps things in memory as much as possible. Unlike traditional data processing engines like MapReduce, Spark processes data in memory, RAM, making it significantly faster for many data processing tasks. This means it can run programs up to 100 times faster for certain workloads. So what can Spark do? Let's break it down. 1. Data processing. Spark handles batch processing and real-time stream processing, so whether you're analyzing historical logs or reacting to live data, Spark's got you covered. 2. Machine learning. With Spark offers scalable machine learning algorithms right out of the box. 3. SQL analytics. Using Spark SQL, you can query your data using SQL syntax, making it easy to integrate with tools and dashboards. 4. Graph processing. Need to analyze networks or relationships? Spark's GraphX lets you run graph computations at scale. Spark works with data from all kinds of sources: HDFS, Amazon S3, Apache Hive, JDBC, Cassandra, and many more. Why use Apache Spark? Apache Spark has gained massive popularity for several reasons. Speed, in-memory computation can make Spark up to 100x faster than MapReduce for certain applications. Ease of use. APIs are available in Java, Python, SQL, and R, making it accessible to a wide range of developers. Versatility. It supports batch processing, real-time streaming, machine learning, and graph analytics. Scalability. Spark can run on a single laptop or scale up to thousands of nodes in a cluster. Core components of Apache Spark. Apache Spark is modular in nature, consisting of several core components that work together to handle different types of workloads. 1. Spark Core. This is the foundation of the entire Spark ecosystem. It handles basic functions such as task scheduling, memory management, fault recovery, I/O operations. 2. Spark SQL. This module allows querying structured data using SQL syntax. It also provides a programming abstraction called data frame and supports integration with Hive and JDBC. 3. Spark Streaming. Spark Streaming enables real-time data processing. It ingests data in small batches and processes them quickly, ideal for scenarios like fraud detection, log processing, or sensor data analysis. 4. Machine Learning Library. A scalable machine learning library built on Spark and provides tools for classification, regression, clustering, and recommendation, all distributed across the cluster. 5. GraphX. This component is used for graph processing. It supports operations like graph parallel computation and provides an API for building and transforming graphs. It supports multiple languages too, so whether you prefer Python, Java, or R, Spark has an API for you. How Apache Spark works. At a high level, Spark operates in the following way. Driver program. The application starts with a driver program that defines the main function. Cluster manager. The driver communicates with a cluster manager, like Yarn, or to manage resources. Executors. The cluster manager launches executors, worker nodes, on the cluster to perform computations and store data. Tasks: the driver distributes tasks to these executors and monitors execution. Spark uses a directed acyclic graph, DAG, to optimize job execution, breaking it down into a series of stages and tasks. Spark can run on a single machine, a cluster of machines, or in the cloud, and it's compatible with cluster managers like Yarn and. Today, Spark powers everything from fraud detection to recommendation engines, IoT analytics to genomics research. In short, Apache Spark is the engine behind intelligent, high-speed data at scale. So, whether you're a data engineer, a data scientist, or just curious about how big data is managed, Spark is a tool worth learning. Ready to light up your data? Dive deeper into Apache Spark.